Okay, let's dive into this explainer. For nearly a century, almost every single new American car startup went bankrupt. I mean, it was an industry literally cemented in stone. These massive companies had perfectly fine-tuned the internal combustion engine, they had these sprawling, deeply entrenched supply chains, and they were locked into a very rigid, specific way of doing business. But then, the script was completely flipped. So today, we're going to look closely at the engineering, the economics, and the hard evidence of how exactly one underdog company forced a completely stagnant global industry to fundamentally reinvent itself.
Think about the last traditional car you bought. The day you drove it off that dealer lot, it was a finished product, right? That was just the standard assumption for all of us. So when we ask how an industry that seemed entirely impossible to disrupt was suddenly reshaped, well, the answer isn't just that someone finally built an electric car. Honestly, electric cars have been attempted before, and they largely failed. Rather, it was the introduction of an entirely new philosophy of mobility. It wasn't just about swapping out the fuel source, it was about completely changing how a car is designed, how it's updated, how it's sold, and ultimately how it's experienced by the driver.
Back in the early 2000s, launching an electric vehicle startup out in Silicon Valley wasn't just seen as risky. Industry experts literally considered it a guaranteed failure. Founded in 2003 by Martin Eberhard and Mark Tarpenning, with Elon Musk providing some absolutely crucial early investment a year later in 2004, they were starting from absolutely nothing. By 2008, they launched the Roadster, which proved that an EV didn't just have to be a glorified golf cart, it could actually be highly desirable and incredibly fast. But it was the 2012 debut of the Model S that truly put the legacy industry on notice. Even then, a lot of legacy executives just dismissed it as a niche novelty for tech enthusiasts.
All right, let's look at Layer 1, computers on wheels.
The biggest advantage this underdog had actually wasn't the battery at all. It was a complete reimagining of the vehicle's architecture. For generations, traditional automakers operated on a very strict hardware-first model. To put that into perspective, a traditional legacy car uses up to 150 separate electronic control units, and they source those from dozens of different suppliers. So you have one computer for the windshield wipers, a completely different one for the brakes, and yet another one just for the windows. It's an uncoordinated mess. But by adopting a software-first approach, this new architecture replaced all that fragmentation with a unified, centralized computing brain, all controlled by one massive touchscreen interface.
And because of that centralized brain, we get something truly revolutionary. The car actually keeps improving after you buy it. Think of how your smartphone magically updates overnight. Now apply that same logic to a 2-ton machine. For example, when Consumer Reports found a braking distance issue in the early Model 3, legacy automakers would have initiated this massive, wildly expensive physical recall, forcing everyone to go wait at a dealership. Instead, the engineers simply tweaked the code and fixed the stopping distance overnight with an over-the-air update. That right there fundamentally shifted consumer expectations forever.
Moving right along to Layer 2, the machine that builds the machine.
It turns out designing a cool car is kind of the easy part. Building millions of them efficiently without going totally bankrupt, that is where the real magic has to happen. Instead of relying entirely on a sprawling, super fragile network of third-party suppliers for every single component, the strategy shifted heavily to vertical integration. By bringing massive chunks of the supply chain in-house, and this is key, heavily integrating battery cell production right next to the assembly line inside these massive gigafactories, they managed to completely bypass the standard bottlenecks that have plagued traditional automakers for decades. Now, the absolute crown jewel of this manufacturing pivot is something called gigacasting. Let's put some numbers to this so we can really understand the scale. Traditional car frames require stamping out and welding together over 70 individual pieces of metal. That takes dozens of robots and a massive amount of factory floor space. Gigacasting changes the game entirely. They inject molten metal into a massive mold, creating a single, giant piece of the car's structure in one shot. This radically streamlines the assembly line, strips out excess vehicle weight, and drastically cuts down on manufacturing costs. It's a real game changer.
Which brings us to Layer 3, the industry ripple effect and the numbers.
These internal engineering breakthroughs, they didn't just happen in a vacuum. They directly sent shockwaves through the entire global market. But to be totally objective here, scaling this up was absolutely brutal. During the ramp-up of the more affordable Model 3, the company faced what was notoriously called production hell. I mean, the CEO was literally sleeping on the factory floor trying to fix assembly bottlenecks. But they pushed through. The production volume absolutely skyrocketed, and that officially shifted them from a boutique California brand into a mass-market powerhouse delivering millions of vehicles globally.
Suddenly, the sleeping giants of the industry woke up and realized they were losing ground and fast. The global EV pie was growing exponentially. Competitors like China's BYD and massive conglomerates like the Volkswagen Group recognized that if they didn't pivot and adapt to this EV transition immediately, they risked complete obsolescence. The long era of internal combustion dominance was visibly cracking, and the race to capture the electric market was officially on.
Beyond just vehicle sales, the economic viability of the entire EV transition was being proven in real time. But one of the most brilliant strategic moves was solving range anxiety. Early on, legacy automakers just assumed third parties would step in and build EV charging stations, kind of like how oil companies built gas stations. Well, Tesla realized they had to build the infrastructure themselves if they actually wanted to sell the cars. That sprawling supercharger network created a massive competitive moat. This combination of profitability and infrastructure dominance is exactly what commanded such a towering capitalization on Wall Street.
And the capitulation of the old guard has been immense. We aren't just talking about rolling out a few new hybrid models here. Giants like Ford, General Motors, Toyota, and Hyundai are entirely retooling century-old engine plants. They're out there building massive new battery factories from the ground up and desperately securing their own supply chains. Nearly every major legacy automaker is now pouring unimaginable billions into a government-incentivized future that they were, quite frankly, largely dragged into by a Silicon Valley startup.
But it's certainly not all smooth sailing. Let's look at Layer 4, the big challenges.
Navigating this transition comes with massive friction. Building an EV at this kind of scale means you aren't just an automaker anymore. You essentially become a mining logistics company. Sourcing massive quantities of lithium, cobalt, and rare earth materials involves incredibly complex global and geopolitical tensions. And doing all of this while trying to maintain strict quality control and defending profit margins during intense industry-wide price wars, that's a massive daily headache for the entire sector.
Looking ahead, the metric for a truly great car is no longer horsepower or 0 to 60 times. It's artificial intelligence. The shift toward full self-driving technology is arguably one of the hardest engineering problems of our time. And it's important to note here that teaching a car to interpret a chaotic city street isn't just a software issue. It is a massive regulatory and ethical battleground under intense public scrutiny. Achieving widespread mass approval for this is still far, far from settled.
So what's next? Layer 5. The future of mobility.
Where does this leave us for the next decade of transportation? If the last 10 years were about electrifying the car, the next 10 are about fundamentally redefining what a car even is. Think about the connective tissue here. If you master artificial intelligence for autonomous driving, you can put that exact same AI into a humanoid robot. If you master battery technology for millions of cars, you can connect them in a vehicle-to-grid system to literally stabilize power for entire neighborhoods. The scope is expanding way, way beyond the garage.
Ultimately, the companies that change history rarely invent everything. They change the direction that everyone else follows. They didn't invent the electric car, just like Apple didn't invent the mobile phone. But they packaged the software, the engineering, and the manufacturing into a product that shifted the entire global paradigm. The transformation of modern transportation simply cannot be explained without acknowledging this specific catalyst.
We've seen how a software-first approach can completely topple 100-year-old assumptions. You now have a deep, structured understanding of the architectural and economic forces that completely disrupted global automotive transit. So, take a look around at the entrenched, legacy systems that we rely on every single day. Who is going to force them to reinvent themselves next? Thanks for joining me on this explainer, and I'll see you in the next one.
Thanks for watching World Decoded. Make sure to like and share, subscribe, and stay curious.